Okay. Is my sound better now?
Yes, ma'am.
Okay. Let's hope it stays the same way.
Ma'am, you are host now. You can share the screen.
Yeah, sure. I'm sharing the screen. Can you see my screen? But let's see, we said that we had two slits. The width of the both of the slits is same. Let's say the width is B.
Hello.
Hanji Shivani. Hello. Shivani, can you? Hello, Shivani, can you hear me? बच्चों आवाज आ रही है मेरी?
Yes, ma'am.
Okay. Before we start class, since we are already a bit late, I need to make an announcement. आप लोग क्विज में अपीयर होने के लिए जाएं. Okay. आप लोग जब क्विज में अपीयर होने जाएं, make sure you have your roll number IDs either remembered or you have them accessible. आप क्विज में लॉगिन नहीं कर पाएंगे जब तक आपके पास आपका रोल नंबर नहीं होगा. So last time some of the students had this issue. They said कि हमें पता नहीं था, हमको अपना आई कार्ड ढूंढने में 5 मिनट लग गए. And the quiz will be of 10 or 12 minutes duration का होगा. 10 आपके पास MCQ होंगे, न्यूमेरिकल्स नहीं होंगे क्विज में. That was all about quiz. किसी को और कोई डाउट है क्विज से रिलेटेड? क्विज इवनिंग में 7 o'clock. और ये सब इंफॉर्मेशन, there is a meeting at 4 today, so probably by 5:30 or so ये सब इंफॉर्मेशन LMS पे भी अपलोडेड हो जाएगी. तो आप लोग प्लीज इवनिंग में एक बार LMS जरूर चेक कर लीजिएगा.
ओके मैम.
And I'm sorry about the internet quality today. Somehow it's not working. And hopefully now it stays stable. So we said that we had two slits and both of the slits, they are of the same width. दोनों slit की जो width है वो same है. And in दोनों के बीच में जो opaqueness थी, we said this was A. And now there is a there is a convex lens here and here is your screen. And let's say at point P, we are looking at the intensity. So what would happen? आपके slit 1 से diffraction होके rays जो है वो P पे पहुंचेंगी. And the second slit, this is your first slit and this is your second slit. So second slit से भी आपके पास में rays जो है वो यहाँ पे पहुंचेंगी. But the wavelets which are reaching from the second slit, they will travel some distance extra. वो extra distance आप कैसे निकालोगे? आप यहाँ से perpendicular draw कर दोगे. And let's say if these rays are getting diffracted by angle theta, तो second slit से भी जो wavelets होंगी, they are also going to be diffracted by angle theta. अगर ये angle theta है, then this angle is going to be 90 minus theta, and then this angle would be again equal to theta now. And now if this is your point A1, this is your point B1, and let's say this point is B1 prime. अगर आप फर्स्ट स्लिट को n number of points में हमने सिंगल स्लिट में डिवाइड किया था, we can divide the second slit also into n number of points. And for every single point on slit 1, there is going to be a point on the slit 2 also, because both of the slits, we said they are of the same size. Now the wavelets that are going to start from the second slit, they are going to travel this much distance extra. How much is this distance? This distance we can calculate using simple trigonometry, where we say that this upon A1 B1 is equal to sine theta. A1 B1 is A plus B. And that we can call as D, which is also called as grating element, which we'll talk about when we'll talk about n-slit diffraction pattern. So this means that simply your B1 B1 prime is equal to D sine theta. Or the wavelets that are going to start from second slit, they will be traveling this much distance extra. So if the disturbances due to first slit, and let's call them E1, are given by this expression, A sine beta over beta, cosine of omega t minus beta. We derived this expression for the single slit. Then the wavelets
Ma'am,
that
your
are
voice is lagging.
Lagging.
this is the best internet I can find. I'm already connected to my phone. The institute internet is. Okay, I'll try to find some better internet tomorrow for sure. So as I said, the wavelets that are going to start from the second slit, they will be traveling some extra distance, and that extra distance was basically given by perpendicular, which is drawn from slit 1 to slit 2, and this extra distance is d sine theta. So now if you are saying that due to your slit 1, if this was your disturbances, then due to the second slit, the disturbances would be given by this expression. We did that in the previous class, but it wasn't somehow recorded. This alpha factor. Okay, so let me try for the last time. And if it doesn't work, let's please reschedule your class on Saturday whenever you are free. I think you're free from 12:10 to 1.
Ma'am, there is problem in voice.
Okay. Can we reschedule your class on Saturday? Students. Hello?
Yes, ma'am.
Okay, ma'am.
Or just let me give the last try this time. अगर अब की बार भी नहीं होता है, there is no point in connecting it time and again. So I'll try for the last. Okay. And if your disturbances, if this gets disconnected this time, I'll not reconnect, and then we'll reschedule your class Saturday. So this is the last time we are trying it. Then your disturbances due to second slit would be given by this expression. Where alpha is nothing, but alpha is the phase constant by which the wavelets which are starting from the second slit, they are going to lag. And this alpha is going to be 2 pi by lambda into d sine theta. Because remember, d sine theta was the path difference. अगर आपका path में इतना lag करेगा, तो phase में 2 pi by lambda multiplied by the path difference, उससे वो lag करना start कर देगा. Because you know 2 pi अगर आपका phase है, that is basically equivalent to 1 wavelength, वो आपकी lambda के equivalent होगा. And then we said that the resultant disturbances would be sum of these two terms. We already discussed that in the previous class, and I'm just going through it quickly. And then in the bracket, you will have cosine of omega t minus beta plus cosine of omega t minus beta minus alpha. And this would be basically a sine beta over beta. Cos A plus cos B का अगर आप यहाँ पे expression लगा दोगे, that is nothing but 2 times cos A plus B over 2, cos A minus B over 2. So this would be basically equal to 2 times cosine of, इन दोनों का अगर आप sum करोगे, you will have this. Into A minus B अगर आप करोगे, you will have this. By 2. And this is nothing but A sine beta over beta 2 आप बाहर ले आइए, यहाँ पे you will have cosine of omega t minus beta minus alpha over 2 and here you will have omega t से आपका omega t cancel हो गया, बीटा से this beta would become plus, sorry ये वहां पे माइनस था तो वो प्लस हो जाएगा, ये कैंसिल हो जाएगा, you will have cosine of alpha over 2. So this will be your resultant disturbances at any point P on the screen if there are two slits that you are dealing with. यहाँ पे टाइम की जो टर्म है उसको सेपरेट कर दीजिए, उसके अलावा बाकी जो भी टर्म्स हैं they basically represent the amplitude which are these terms here. So in this case then you can say that your E is basically equal to 2 times A sine beta over beta cosine of alpha over 2 cosine of omega t minus beta minus alpha over 2. This would be the expression for the disturbance on the screen. And let me remind you, I'm talking about this case here. Here is your screen. You can take any point of your choice on the screen. आप जो कोई भी point चाहें वो आप ले सकते हैं. Here beta we already defined in the single slit pattern. Beta we said is equal to pi over lambda b sin theta. जहां पे b आपका स्लिट साइज है. अल्फा हम लोगों ने अभी अभी डिफाइन किया था 2 पाई बाई लैम्डा इनटू d sin theta. Is my sound better now?
Yes, ma'am.
Okay. This first term now corresponds to amplitude. And the term which has time into it, this basically corresponds to the phase, which will basically tell you how does your this disturbances at any point P. They are going to vary as a function of time. Time के साथ में कैसी उसकी variation होगी. Usually what happens is that this variation with respect to time is usually so fast that our eyes are not sensitive enough to basically identify these time variations. अगर आप electromagnetic waves की बात करें which travels with the speed of light, तो यहाँ पे with respect to time, because आपके electromagnetic waves में this is how the displacement is basically going to look like as a function of time. But that variation is so fast that our eyes are usually not sensitive to that variation. So that is why usually whenever we talk about the intensity, we basically focus on the amplitude only. Intensity we know is basically amplitude square. So that means here your I would be equal to 4 times A square sine square beta over beta square into cos square alpha by 2. A square we defined as I naught in the single slit. So I can then say that this is equal to I naught sine square beta over beta square into cos square alpha by 2. This is your resultant intensity on the screen due to two slits. Now, using this expression, we can go back and get Young's double slit expression. Remember in the Young's double slit expression, these slits, they were basically point holes. अगर ये point hole होंगे तो B would tend to 0, right? आपकी slit would tend to 0 in that case if these slits are basically point holes. If your B tends to 0, that means your beta tends to 0. अगर आपका B goes to 0, then your beta goes to 0. And if your beta goes to 0, your sin beta would tend to beta basically. And ये वाला जो expression में, ये वाला जो portion है, that would become equal to 1. And your resultant intensity would be 4 times I naught cos square alpha by 2. And ये वाला जो expression है, this is similar to your Young's double slit expression. Young's के double slit expression में आपका resultant intensity distribution है, it comes in this form. Because of the finiteness of these slits, you have this additional expression now. ये वाला जो expression है, sin square beta or beta square, if you remember, we had this expression in single slit also. Right? In the single slit, your intensity was equal to I naught sine square beta over beta square. So this term basically represents your diffraction due to single slit. और ये जो second वाली term है, This represents your interference due to 2-point sources which are separated by distance d. Remember, alpha is a function of d. Alpha हमने जो एंगल डिफाइन किया है that is defined as 2 pi by lambda into d sin theta and alpha is a function of d. So ये वाली जो टर्म है cos square alpha by 2 ये आपका बेसिकली इंटरफेरेंस रिप्रेजेंट करती है. sin square बीटा और बीटा स्क्वायर है वो आपकी डायफ्रैक्शन रिप्रेजेंट करती है. Hence स्क्रीन पे आप जो रिजल्टेंट इंटेंसिटी देखोगे वो आपका इन दोनों का सुपरपोजिशन होगा. सुपरपोजिशन ऑफ सिंगल स्लिट डायफ्रैक्शन एंड डबल स्लिट इंटरफेरेंस. दोनों का सुपरपोजिशन आप करोगे तो आपको रिजल्टेंट इंटेंसिटी स्क्रीन पे दिखाई देगी. Let me first talk about minimum and maximum, and then I'll show you pictorially how would this intensity would look like if you superimpose these two terms. यहाँ पे आपका intensity का expression, if your intensity expression is given by this term. Where we are saying that beta is pi over lambda into d sin theta and alpha is 2 pi by lambda into d sin theta. Let's first talk about the minimas. Minima would mean your intensity being equal to 0. So you can have intensity 0 in two ways. Either your this term is 0 or your this term is 0, right? If any one of these terms is 0, then the product of both of the terms would be 0 and your resultant intensity would be 0. So for minima, what you would like to have, your sin beta is equal to 0. But remember, your beta should not be equal to 0. क्योंकि अगर आपका बीटा भी 0 हो गया तो you will have 0 upon 0 which is an indeterminate quantity, जो कि आपकी indeterminate quantity हो जाएगी. And we already know from single slit, when your beta is equal to 0, you get the central maxima. जब आपका beta 0 होगा तो आपको central maxima मिलेगा. So for minima, either your sin beta could be 0, but your beta should not be equal to 0, or the second condition is that your this could be 0. चाहे ये 0 हो या ये 0 हो, आपकी जो resultant intensity है that would become 0 in that case. What does this mean? If your sin beta is 0, that means your beta is equal to m pi, but your m is not equal to 0. क्योंकि अगर आपका m 0 हो गया तो beta 0 हो जाएगा, which we already excluded. So your m has to start from 1 onwards. That means beta की वैल्यू यहाँ पे plug in कर दीजिए. Pi over lambda b sin theta is equal to m pi. ये कैंसिल हो गया. b sin theta is equal to m lambda. अगर ये कंडीशन किसी भी पर्टिकुलर वैल्यू ऑफ थीटा पे सेटिस्फाइड होगी तो वहां पे आपकी रिजल्टेंट इंटेंसिटी वुड बी 0. The second scenario is when your cos alpha by 2 is equal to 0. That means your alpha by 2 is equal to pi by 2, 3 pi by 2, 5 by 2, 7 pi by 2, and so on. Or you can say that 1 by 2, plug in the value of alpha. Alpha is 2 pi by lambda into d sin theta. And this I can write as 2n minus 1 lambda by 2, where your n starts from 1 onwards. n की वैल्यू अगर आप यहाँ पे 1 प्लग इन करोगे, सॉरी आई शुड राइट पाई बाई 2. n की वैल्यू अगर आप यहाँ पे 1 प्लग इन करोगे तो आपके पास पाई बाई 2 आ गया. n की वैल्यू 2 प्लग इन करोगे 3 पाई बाई 2 आ गया. n की वैल्यू अगर आप 3 प्लग इन करोगे तो आपके पास 5 पाई बाई 2 आ जाएगा, एंड सो ऑन. सो दैट मीन्स बेसिकली 2 से आपका 2 कैंसिल हो गया, पाई से आपका पाई कैंसिल हो गया. That your d sin theta is equal to 2n minus 1 lambda by 2, where your n starts from 1 on 2 and 3 so on. If either of these conditions, चाहे ये वाली condition satisfied हो या ये वाली हो, आपका रिजल्टेंट इंटेंसिटी जो है इन दैट केस वुड बी इक्वल टू 0। या तो आपका डायफ्रैक्शन ये कह रहा है कि वहां पे रिजल्टेंट इंटेंसिटी 0 आना चाहिए, या आपका इंटरफेरेंस ये कह रहा है कि आपकी रिजल्टेंट इंटेंसिटी 0 आनी चाहिए। इन बोथ ऑफ द केसेस आपकी जो इंटेंसिटी स्क्रीन पे होगी वो 0 होगी। सो whenever this condition is satisfied or this condition is satisfied, आपकी intensity है वो 0 होगी उस केस में। This conditions would correspond to conditions of minima. Now, if we talk about condition of maxima, your expression is this. अब अगर आप मैक्सिमा की बात करते हैं, मैक्सिमा में इन डबल स्लिट एज वेल एज एन स्लिट हम सिर्फ इंटरफेरेंस वाली टर्म लेते हैं। The reason is that diffraction वाली term basically provides you envelope for the your complete pattern, and I'll show you very briefly what do I mean by saying that your diffraction pattern basically provides you envelope for that. But for the time being, trust me when I say that your maxima on the screen would be whenever your this term is maximum, and we know that the maximum value of cosine is equal to cos, here you have cos square, so the maximum value of cos square is equal to 1. That means whenever your cos alpha by 2 is equal to plus or minus 1, in that case your cos square alpha by 2 would be equal to 1. So this means that we would like our alpha by 2 to be equal to 0, pi, 2 pi, 3 pi, and so on. 0 cos 0 is 1, cos pi is minus 1, cos 2 pi is again plus 1, cos 3 pi is minus 1, and so on. Again, if you plug in the value of alpha, and let's call these as p pi, where p can have any value from 0 onwards. यहाँ से 2 से आपका 2 कैंसिल हो गया, pi से आपका pi कैंसिल हो गया. So what you will get would be that your d sin theta is equal to p lambda, where your p could be 0, 1, 2, 3, and so on. So whenever this condition is satisfied, you will get your maxima on the screen. अगर आपका d sin theta 2n minus 1 lambda by 2 है तो आपका मिनिमा होगा, और अगर d sin theta n lambda कह लो या p lambda कह लो या q lambda कह लो, it doesn't make any difference. M and p q are simply to denote you have something which could take several values 1 2 3 or 0 1 2 3 so on. So this is your condition of maxima. Now these two conditions, ये आपकी जो maxima की condition है और ये maxima की condition है d sin theta 2n minus 1 lambda by 2. These are exclusive condition, right? क्या तो या तो आपका d sin theta 1 लैम्डा हो सकता है, 2 लैम्डा हो सकता है, 3 लैम्डा हो सकता है, या लैम्डा बाई 2, 3 लैम्डा बाई 2, 5 लैम्डा बाई 2 हो सकता है. दोनों कंडीशन साइमल्टेनियसली सेटिस्फाइड नहीं होंगी, राइट? आइदर योर d sin theta could be an odd multiple of lambda by 2 or it could be an even multiple of lambda by 2. ये दोनों कंडीशंस कभी भी साइमल्टेनियसली सेटिस्फाइड नहीं होंगी. So we are okay with these two conditions, but there is a possibility when your diffraction is saying, ये वाली जो condition है, this is basically coming from sin beta being equal to 0, which basically corresponds to your diffraction term. So there could be scenario when your diffraction is saying that there should be minimum, but your interference is saying there should be a maximum at those points. So those particular scenarios are called as missing orders. When you have the interference maxima, which basically says that d sin theta is equal to p lambda, where your p can take value 0, 1, 2, 3, and so on, which is your this condition. But your diffraction is saying that there should be a minima. which basically means that your B sine theta is equal to, I don't know if I used M or N, M lambda. M can take value. So remember, there is a relationship between D and B. D is nothing but A plus B. B जो आपकी स्लिट विड्थ है, A आपकी जो दोनों स्लिट विड्थ के बीच में, इन दोनों स्लिट्स के बीच में, that opaqueness is basically A. And this was our B. So there is a relationship between D and B. At whatever value of theta, यहाँ पे अगर आपने वेवलेंथ फिक्स कर दी है, क्योंकि आपने लेट्स से सोडियम का लैंप यूज किया है, तो योर वेवलेंथ इज फिक्स्ड. बी एंड डी आर आल्सो फिक्स्ड, क्योंकि ऐसा नहीं हो सकता कि आप एक्सपेरिमेंट के बीच में स्लिट की विड्थ आप चेंज कर दें. सो यू हैव द साइन थीटा. साइन थीटा बेसिकली depends on the on what location of screen you are looking at. So there would be certain values of theta at which both of these conditions can be satisfied simultaneously. And जहां कहीं पे भी ये दोनों condition simultaneously satisfy होंगे, even though your interference term is predicting a maxima, but because your diffraction is saying there should be a minimum, so there would be a minimum on the screen. And your resultant intensity would be zero in that case. आपकी जो resultant intensity है वो zero होगी. An example of this could be, for example, let's take when your A is equal to B. That means your D is simply equal to 2 times B. अब अगर आप यहाँ पे plug in करो, you are saying that 2B sin theta is equal to P lambda and B sin theta is equal to M lambda. एक को दूसरे से डिवाइड कर दीजिए. B sin theta से B sin theta कैंसिल हो गया, लैम्डा से लैम्डा कैंसिल हो गया. That means P is equal to 2M. So जब कभी भी P की वैल्यू 2 होगी, P की वैल्यू 4 होगी, M की वैल्यू जब आप 2 करोगे तो P की वैल्यू 4 हो जाएगी, M की वैल्यू जब आप 3 करोगे तो P की वैल्यू 6 हो जाएगी. तो वो जो ऑर्डर है, इवन दो इंटरफेरेंस इज सेइंग कि जब P की वैल्यू 2, 4, 6 होगी आपको मैक्सिमम दिखाई देना चाहिए, पर बिकॉज ऑफ द डायफ्रैक्शन मिनिमा आपकी रिजल्टेंट इंटेंसिटी जो है वो उस केस में 0 हो जाएगी at these particular values of P, and that is why these are called as missing order. हम इनको missing orders बोलते हैं. Let me show you the diffraction pattern pictorially now. How would it look like? If you look at this screen here, the top portion here, this one is basically your single slit diffraction pattern. This is how your single slit diffraction pattern is supposed to look like. The bottom here, where all the intensities are constant, this one basically corresponds to your double slit interference pattern, which is your Young's double slit interference pattern. Now, if you superimpose both of them, अगर आप इन दोनों को सुपर इम्पोज एक दूसरे के ऊपर कर देते हो, दिस इज 1 and let's say this is 2, what you get is 3, which is basically a combined pattern and which is the outcome of double slit diffraction, जहां पे आपका diffraction और interference ने एक दूसरे के ऊपर सुपर इम्पोज किया है. And जहां, and when I was saying diffraction basically defines the envelope, that basically means that ये आपकी जो boundary है that is defined by the diffraction here. And उसके अंदर जहां जहां कहीं भी आपका इंटरफेरेंस मैक्सिमम प्रेडिक्ट कर रहा है, वहां वहां पे आपको मैक्सिमम इंटेंसिटी जो है वो ऑब्जर्व होगी. मिसिंग ऑर्डर का मतलब यहाँ पे ये है कि फॉर एग्जांपल, लेट मी टेक अ हाइपोथेटिकल पॉइंट हियर. लेट्स से दैट एट दिस पॉइंट let me draw a straight line from this point onwards through the top of this one. At this point, your interference is saying that you should have a maximum, right? इसके center के through अगर मैं pass कराती हूँ एक straight line, your interference is predicting that there should be a maximum intensity. But because your diffraction is saying that there should be a minimum intensity. तो अगर even though your interference is saying that maximum intensity should be on the screen, but डायफ्रैक्शन की वजह से आपकी जो रिजल्टेंट इंटेंसिटी यहाँ पे होगी दैट इज बेसिकली 0 एंड दीज आर कॉल्ड एज मिसिंग ऑर्डर्स। जहां पे आई एम रिपीटिंग दैट अगेन, जहां पे आपके इंटरफेरेंस वाज प्रेडिक्टिंग टू बी अ मैक्सिमम, बट क्योंकि आपके डायफ्रैक्शन की इंटेंसिटी 0 थी, सो योर रिजल्टेंट इंटेंसिटी वाज 0 ऑन द स्क्रीन एंड दोज आर कॉल्ड एज मिसिंग ऑर्डर्स। इनको हम मिसिंग ऑर्डर बोलते हैं। I'll show you one more example of this. Can you see my screen here? Hello?
Yes, ma'am. It's
Yes, ma'am.
Okay. So on this screen, it's a double slit intensity pattern is shown. What you can control is that you can control the slit width. आप जो slit की width है basically. Look, if I'm scrolling it, यहाँ पे ये जो red basically है, that shows your slit width and it is increasing continuously. And now this is shown to be minimum is the width of the slit as per this diagram, and this corresponds to distance between slits. ये आपकी एक slit है, ये आपकी second slit है. इन दोनों के बीच में distance जो है वो आप adjust कर सकते हो. And look the effect of changing the distance between these two slits. Similarly, there would be an effect of slit width also, कि आपकी slit की width वो कितनी होगी, and distance to the screen. You can also, at the bottom, you can change the color to red, green or violet. You can use the single slit also. आप यहाँ से single slit का भी diffraction का जो pattern है, वो यहाँ से आप देख सकते हो. This would be a single slit diffraction pattern. ये आपका principal maxima होगा, या central maxima होगा, ये आपका next maxima होगा. You can do double source, which would be basically Young's double slit, जहाँ पे आपकी intensity जो है वो uniform रहेगी. And then there is double slit, जहां पे आपकी इंटेंसिटी जो है वो सुपरपोजिशन है of interference and diffraction. दोनों का सुपरपोजिशन है आपका स्क्रीन पे. So play around with the numbers here. आप slit width change करके देखिए, distance between the slits change करके देखिए. जैसे जैसे आप distance slits के बीच का increase करते जा रहे हो, it seems कि आपके यहाँ जो central maxima है उसके बीच में interference के ज्यादा maxima enter करते जा रहे हैं. And this is distance to the screen. आपका screen और slit के बीच में distance है. How much is that distance? So just fiddle around with these numbers. PPT में एक और link दिया गया है. So please try to have a go at the other link also and try to see the interference pattern. In the second link, you can see the interference pattern. अगर आपकी slit है, rather than being a very thin slit, अगर वो एक rectangular slit होगी तो क्या होगा, वो एक kind of circular slit होगी तो आपका intensity pattern क्या होगा, and so on. All those things you can see on the screen using the second link. After this, the next what we are going to discuss is the N-slit diffraction pattern, which is very easy if you know the single slit and the double slit. So now rather than having one or two slits, you have a large number of slits, and these large number of slits could be even two slits also. The expression for the intensity that we are going to derive for N slit, that is applicable to the double slit into diffraction pattern also. So these N slits, they can be two slits, they can be three slits, they could be 300 slit, or they could be 3000 slits also. आप लैब में एक डायफ्रैक्शन ग्रेटिंग का एक्सपेरिमेंट करते हो, डिस्पर्सिव पावर मेजर करने का, डायफ्रैक्शन ग्रेटिंग का. Diffraction grating is nothing but a typical example of N-slit diffraction pattern. So you have a large number of slits here. We are also going to assume that the width of all those slits is same. सभी की सभी slit हैं, they are of the same size. So that means if we are saying that the width of this slit is D, the width of the next slit would be B, sorry, B, we were taking the slit width to be B throughout. So let's take it B even now also. So this slit width also will be B, and this would also be B. If this opaque material between these two slits was A, so ये भी A होगा and ये भी A होगा. we defined B plus AB to be D. So we can still define it the same way. Now, let's say that you had a lens and here is your screen. The rays which will be diffracted from here, and let's say you're looking at point P here. Again, you can divide each one of the slit into n number of point. सेकेंड स्लिट की वजह से भी आपके वेवलेट्स जो हैं वो स्टार्ट होंगे एंड दे विल गो ऑन द पॉइंट पी. नेक्स्ट स्लिट की वजह से भी आपके वेवलेट्स हैं, दे विल रीच देयर एंड लेट्स से दैट नेक्स्ट स्लिट इज C1 and the last point is CN. And then I haven't shown a lot many slits. Let's say that this is your nth slit. यहां से भी आपके जो वेवलेट्स ओरिजिनेट होंगे, दे विल आल्सो रीच पॉइंट P. पॉइंट P पे आपको जो इंटेंसिटी ऑब्जर्व होगी, दैट वुड बी बेसिकली ड्यू टू सुपरपोजिशन ऑफ डिस्टर्बेंसेस व्हिच आर स्टार्टिंग फ्रॉम ईच वन ऑफ द सिंगल स्लिट्स. सभी स्लिट्स की वजह से जो डिस्टर्बेंसेस होंगे पॉइंट P पे आपको जो दिखाई देगा, दैट वुड बी द रिजल्टेंट ऑफ ऑल दोस पॉइंट्स हियर. अगेन व्हाट यू कैन डू, यहां से एक परपेंडिकुलर अगर आप ड्रॉ कर देंगे, लेट्स से दैट पॉइंट इज B1 प्राइम. सो विद रिस्पेक्ट टू A, जो आपके वेवलेट्स सेकेंड स्लिट से स्टार्ट होंगे, इफ दिस इज योर स्लिट 1 and let's say this is your slit 2, this is your slit 3 and let's say this is your nth slit. So second slit से जो wavelet start होंगे, they will be traveling this much distance extra. And now if this distance is D and your theta is the angle of diffraction, then this angle is again theta. This distance is going to be equal to D sin theta. Similarly, यहां से आप A1 से नेक्स्ट स्लिट पे भी एक परपेंडिकुलर ड्रॉ कर सकते हैं. अब नेक्स्ट स्लिट से जो वेवलेट स्टार्ट होंगे वो इतना डिस्टेंस एक्स्ट्रा ट्रेवल करेंगे. अगर ये डिस्टेंस D था एंड दिस डिस्टेंस इज आल्सो D, नाउ दिस बेसिकली मीन्स दैट योर डिस्टेंस फ्रॉम हियर टू हियर is 2D. If this distance is 2D, then this is going to be 2D sin theta. नेक्स्ट वाली स्लिट पे, यहाँ पे अगर D sin theta हुआ सेकेंड स्लिट में, थर्ड में 2D sin theta हुआ है, तो थर्ड स्लिट में आपका जो है 2D sin theta हुआ है. फोर्थ वाली जो स्लिट में 3D sin theta होगा, फिफ्थ स्लिट में 4D sin theta होगा, nth स्लिट में इट वुड बी n-1D sin theta. अगर आप यहाँ पे एक और perpendicular ड्रॉ कर देंगे and this perpendicular is from here to here. Let me repeat that. सेकेंड स्लिट से जो वेवलेट्स होंगे वो एक्स्ट्रा D sin थीटा ट्रेवल करेंगे. थर्ड स्लिट से 2D sin थीटा करेंगे, फोर्थ से 3D करेंगे, फिफ्थ से 4D करेंगे, तो nth स्लिट से n-1D sin थीटा एक्स्ट्रा डिस्टेंस जो है वो ट्रेवल करेंगे. I think we'll start from here in the next class. I'll end it here. Anyone has any doubt in today's class? And again, I'm sorry about the internet quality.